So in this video, I'm going to explain the next instruction, which is called as a XRA. The meaning of this instruction is exclusively or with accumulator. So here also the operation performed by this instruction will be XOR operation of the accumulator with the specified operand, and after performing this operation, the result will be stored into the accumulator itself. So here, as a opcode of this instruction is, here this will be XRA, and as a operand it will be having that either 8-bit of register or memory. Now we'll see that remaining field later, and first of all we will understand about their operation in detail. So let's say for example, if I am taking this instruction as a XRAD, it means it will perform the logical XOR operation of the accumulator content with the D register content, and after performing this operation, the result will be stored into the accumulator itself. So before execution of this instruction, I am assuming here the content of accumulator, it is 77H, and the content of this D register I am taking here as a 56H. So now we'll see how it is operating here. So this accumulator content is 77H, and this D content here it is 56H. Their binary pattern will be how this 77H can be written 0111 and 0111. Now for this 56H, so this can be written, 5 will be written 0101 and 6 can be written 0110. So as like in the previous video what I had explained about this XOR operation, if both the input are same, then output will be 0. If both the input are same means if either both the inputs should be 00 or both the inputs should be 11, then their XOR operation output will be 0. If both the inputs are different as like 01 or 10, then their output will be 1 here. So as per that rule, from the first stage, that 1 XOR with 0, their output will be 1 here. Their output will be 1 here. And from the second stage, both the input are same, so this will be 0. From the third stage, both the input are same as a 1 and 1, so this will be 0. From the fourth stage, both the input are same as like 0 and 0, so their output will be 0. From the fifth stage, this both the input are same as a 1 and 1, so their output will be 0. From the next stage, 1 XOR with 0, so this both are the different, so their output will be 1. And from the seventh stage, it is same input, so this will be 0. From the eighth stage, which is the last stage, here also their output will be 0. So here if you'll see that what is the output it is coming, it is 0010, it means it is 2, and here 0001, it means it will be 1. So in hex this can be written here, accumulator will store this result as a 21H. Now how will be their impact over the flags, that also we have to see. So as like in the previous instruction as a logical ending, here also sign 0 parity will change as per the result obtained or to reflect the result. Sign 0 parity will change or will alter to show the result or to show this impact over the result. So here we can say that this sign 0 parity, how it is. So this sign bit is 0 here. So this will be this MSB is 0, so sign bit will be 0 here, and this result is non-zero. So that is the reason 0 flag will be 0 here, and the number of ones in this result is 2, that is called even, so it will perform even parity. So parity bit will be 1 here, and unlike to that logical ANDing operation, in this case for this auxiliary carry as well as carry, both the bit irrespective of this result obtained, this will be always reset, because this result, like whatever is the fourth stage, either as a 00 or 01 or 10 or 11, it will never create here the carry. Similarly, from this eighth stage also, whether it is 00, 01, 10, 11, this will never create the extra bit here as a carry bit. So due to that reason, this auxiliary carry and carry will be always reset here in this case. So here we should note we can make a note for this. We can make a note for this here, that sign 0 parity altered to reflect the result. To reflect the result, but this auxiliary carry will be always reset and carry flag will be also always reset irrespective of the result obtained here. So while using this instruction, you must have to know about this flag status. Now we'll talk about their size. So if you see that XRAD, this is the instruction here. So in this instruction, this is having only English alphabet, so their size will be 1 byte here, and their machine cycle will be only 1. The reason behind that, this accumulator is inside the processor, D register is also available inside the processor, then LU unit where this logical operation perform, that is also available in microprocessor itself. So it requires only that one data which is called as a opcode from the memory. So it is only fetching the opcode from the memory. So that is the reason by default it requires only one machine cycle, which is named as opcode fetch machine cycle, and by default the number of T states required for this instruction will be only 4 T states. And here for the memory, so let's say for example, if we are taking the second case as a memory, so let's say if we are writing here XRAM, so by default, as like whatever I had given the explanation in the previous example, this M means here it is having that memory location which is pointed by the content of this HL register pair. So let's say if this H is having 20, L is having 50, so 2050H will be the memory location from where content has to be copied into the microprocessor. So let's say at this point, this is here 2050H. So at this, if it is having the data as a 56H, so this 56H data will be copying from this memory into the microprocessor. It is not cutting the data, it is copying the data. So whenever we are copying the data, it is not going to delete from this place, it will be here also available. So here this 56H will come from the memory to the processor, and this will perform the XOR operation with the accumulator content, and after performing the operation, result will be stored into the accumulator, and as per the result, the sign 0 parity flag will change to reflect the result, and remaining auxiliary carry and carry will be always reset here. So copying means it is not going to change this content like whatever it is available at this 2050H. So even after execution of this instruction, if you check the content at this location 2050H, it will be always 56H in this instruction. So it is going to change only the result which is obtained, and that is copying or that is stored into the accumulator here. So as a size also, if you see that for this instruction XRAM, so this is having only English alphabet, so their size will be 1 byte here. Their size will be 1 byte here, and machine cycle will be 2, as like previous instruction also had explained. So the first machine cycle will be by default opcode fetch, and the second machine cycle to read this memory content here. So that operation is called here as a memory read operation, And as we know that for this opcode fetch it is required 40 state, for memory read it is required 3 state. So here this total number of t states for this one, it will be 4 plus 3, it is here 70 state. Why it is required larger t state compared to the first case as a register, that logic already had explained previously also. So here this we had seen before execution of this instruction. After execution, after execution of this instruction, the content of accumulator will be changed or modified as a 21H, and the content of this D register is not going to change. So it will be same as like 56H. So this is going to be used for this instruction not to change. So here this whatever is the data 77H and 56H, this is going to be perform the ending this XOR operation, and after performing this operation the result will be stored into the accumulator. And how the impact will be over these flags, and how we can find out the rest of the field for this memory case also, these all the bits I had explained with much of clarity. So I hope you understand this instruction in the better way. Thank you.